Good morning, good afternoon, welcome everybody. I'm excited today. We have a really interesting topic to talk through. I'm joined today by Kyle Burdine from Digitize Designs and Greg George from Oqton. And today we will be running through a really interesting use case, a really interesting workflow of reverse engineering and 3D scanning. We'll be digitizing an ex-military helicopter using the brand new NimbleTrack 3D scanning system from Scantech and the Geomagic Design X reverse engineering software developed by Oqton. A few housekeeping bits before I pass over to Kyle and Greg to run through the portion of the presentation. The presentation and the demo that you'll see today is roughly 40 to 45 minutes long, and we will be leaving 15 minutes at the end to answer any questions that you may have. In the GoToWebinar control panel, there is a questions area that I'm sure you can all see. So as we run through the webinar, if you see anything that you want to elaborate on further, or you have questions about any of the technology that you see, feel free to drop your questions in that panel and we will answer them right at the end of that webinar. You'll receive the recording next week, so if you need to drop off for any reason, we hope you don't, but you will absolutely be able to review and catch up. So without further ado, I'll pass over to Greg and Kyle to get into the interesting bit.
Awesome, thanks a lot, Guy. So yeah, today Kyle and I are going to present along the lines of what Guy said. Before we go ahead and jump in, I'll just point out that for those of you that don't know, my name is Greg. I am from the Oqton group that's at 3D Systems, and I'm part of the Geomagic people on this call. And I'm going to cover the Geomagic portion of the presentation. Been in the software area in this category for 20 plus years. I'm responsible for the Geomagic products here at Oqton, which ranges from Design X, Control X, Freeform, all these different things. And I'm the AE manager there. And I have a lot of personal passions as well, such as mountain biking and paddleboarding. But also on the call, we have Kyle, and he is from Digitize. Kyle, tell us a little bit about Digitize.
Yeah, absolutely. So Digitize Design's been around for about 7 years. We represent 3 different brands of scanners currently, Artec, Faro, which a lot of people have maybe heard of. And of course, today we're going to talk about Scantech, and that's the Scantech NimbleTrack, which we'll get into in a minute. And then along with those brands of equipment, we do represent several different brands of softwares, with the flagship software that we represent for reverse engineering Design X and Oqton Geomagic Design X as well too. So we also do some scanning services and things like that as well, but that's a little bit smaller portion of our business. You bet. Little history about myself, kind of like Greg did. Head of sales at Digitize Designs, been here since September 2020. I've been in some sort of measurement field for about the last 11 years, but really in the metrology field for the last 6. And like Greg said, yeah, I have personal passions as well too, but definitely love all the different opportunities we get to see and places we get to go and see and use these useful tools and software with as well.
So we'll start off with the NimbleTrack. So tell us about the NimbleTrack there.
Yeah, thanks, Greg. Yeah, so the NimbleTrack just released by Scantech about, it feels like sooner, but only 2 months ago. It is the first of its kind, really, that I've seen that's metrology grade scanner, handheld scanner, doesn't require targets, and works completely wirelessly just on its own internal network. So it's pretty incredible little piece of equipment that really it's revolutionizing, I think, the way we're going to see 3D scanning moving forward in the industry for all OEMs, all brands everywhere. Yeah, so if I want to get into it a little bit more, they've changed some things with this. This tracker on this is a lot smaller, so some of you have seen maybe those tracker-based type scanners in the past. This is a lot smaller unit, a lot more mobile, a lot more portable. As I said, it's completely wireless, runs off really just a couple of camera batteries. Some batteries, if you see from out there on equipment, are $300, $400, $500, $800. The batteries for this are really like $30 on Amazon. Very, very easy to use, very easy to get, and really, you'll see in the video that we're gonna show you in a minute kind of the operation and how it works and how fast it is. But not to get too salesy, but it measures at about 2.5 million measurements per second, which is about the fastest thing out there, especially for metrology grade. So,
all right, so we'll go ahead and jump into that video for you.
Awesome. Yeah, so I'll go into a little bit here, but basically what we've done, we've worked with many different companies in the past as far as DoD, Department of Defense, aerospace, things like that. And so we wanted to partner with Oqton on this and show this is a Cobra helicopter. It's retired, decommissioned. Obviously, the places we've gone to, we can't share video of that we've been to. So we figured we would scan maybe this decommissioned helicopter that's based. It's in Greenville, South Carolina, where our headquarters is based. And this is our engineer Brian getting all set up there. We scanned most of the sides of this, most of the top, some of the bottom, not a ton. But as you can see with that, all we've got set up there is one little portable. There it is, perfect. So a portable table to set on. We've got the wireless NimbleTrack right there running off just a couple camera batteries, and then powering it all is just a little generator, a battery generator, $1,000 battery generator. It can power this whole system, laptop and everything all day long, and charge batteries at the same time. You can move this around, it's completely portable. Brian scanned everything you're going to see here that Greg will show us later in about a 3-hour window. That's set up, tear down, leave, go back, go away, everything. And so you might be saying, hey, I don't work for the DoD. I'm not a helicopter manufacturer. How is this relevant to me? So what we did is Greg's going to take a lot of different surfaces and different parts of this, particularly this wing and some of those other areas that might be relative to your life. If you maybe make some freeform shapes and things like that, or there's the gun turret down the bottom with the bolt hole pattern on there. Greg's going to show us how Design X can use bolt hole patterns and do a lot of different patterning as well. He can show us how freeform shapes would work, and there's even some pipes in there. So if you get to tubing, he's going to show us some of the wizards relative to that in Design X. But as you can see, Brian's got the 6-foot ladder. He gets up on top of this thing and scans relatively easy. You really need to have a screen, be able to see that computer screen as far as you are, and then scan. You can also see the lasers as you're scanning. So as long as the lasers are active and moving, you know that you're collecting data. If someone really wanted to get next level with it, they could put that on their Apple Watch or some sort of maybe a tablet they could have in front of them as well too. So I could literally be scanning and never have to turn back and look at the screen at all, and I'd be completely wireless and autonomous and scanning and collecting data the entire time. So yeah, I mean, Brian's having a heyday here, scanning all these different parts and areas. But like I said, this was maybe a 3-hour scan total to acquire all this data, as well as download and process and everything too. So that's pretty much what we do here. You hit stop and it starts to build a point cloud, and there's the final point cloud, and then turned into a mesh right there. And we got data pretty much everywhere. There's a couple spots that maybe he didn't collect that I know that Greg wasn't focused on working on. But for the most part, again, it's an entire helicopter, Cobra helicopter scan, large pickup truck or semi or anything else kind of that same scale within just a couple hours. And of course, if I'm doing a small area, it'd be that much faster. So we'll hold the questions till the end, but feel free to throw them in the chat or wherever if you have questions about the scanner, the operation, how to see a demo, all that fun stuff too. So
absolutely, that's awesome. That's an impressive scan. So after you scan that data, you get all this amazing data from that device, and you bring in the information into software. Usually that's kind of where the next transition happens. People usually are starting to take a look at that information and realize that it's a triangle mesh object, and they're like, what do I do with that? And that's where my portion of the presentation comes in, is talking about Geomagic Design X, which is the industry's most comprehensive, accurate 3D scan to CAD solution, reverse engineering for physical parts. What I always say is, if you want to recreate objects, that's what Design X is for, right? So we've been around the market for 20 plus years, been scanning forever here. And really what Design X is our premier solution that can be anywhere between 3 to 10 times faster. Honestly, in larger projects, the more complexity there is, the more speed there is. So, I mean, it could be easily 3 to 20%. But if you're doing more modeling, the more savings that you experience with this solution. And I'll talk about why here as I go through the presentation. But before we get started, this is the workflow that we took for this webinar. So we scan with the NimbleTrack, as Kyle showed, and we bring that information into Design X. And Design X is essentially a CAD modeling tool that also has a scan kernel built in that we've built from the ground up here at Geomagic. And we are able to take that and extract CAD objects from that to then go to whatever output that you want to go. And there's a lot of different deliverables here, whether you want to go to CAD, CNC, or additive in order to go ahead and print some parts or cut parts on CNC or go directly into CAD to redesign and then a lot of times still progress over to CNC anyway. So this is the workflow, and we'll just go ahead and talk about a couple other options in here. You can bring in the scans, and just like we said, one option could be go to a watertight mesh if you're just going to go print. Another one is to create CAD models inside of like a SolidWorks or NX there. And another one is to go ahead and send it over to a CNC package to then just go directly cut off of it. So what we're going to see here is we'll bring in this information that came from the scans that Kyle and his crew gave us. And I'm just showing just all the detail here that, that we're bringing in from the scanning software. And this is a screenshot of the scanning software. And what you do is you can save that out and bring that over to Design X. Now in Design X, I have the ability to do some scan editing functionality as well. So you have a little bit of that in the Scantech software, or you can also do that inside of our software. And sometimes I breeze over this, so I wanted to highlight this a little bit today and just show that while sometimes you may miss an area, obviously the ideal is just to go ahead and scan. I just selected some areas and just to show that we have the ability to hole fill, you have the ability to hide and show strategic areas of the mesh and almost do surgery on an area. And this is, again, just to highlight this functionality that exists in the software. Obviously, Kyle and his crew went ahead and scanned the majority of it, but I wanted to kind of highlight, again, an often overlooked aspect of the software that even if you weren't able to get enough information, that you're able to still work with that inside of Design X and edit it in a lot of different ways. Other things that you can do here is you bring in a scan, but this scan is all one object. So you also have the ability to like separate out. So I can crop out just different components because this helicopter is a giant assembly, right? And I can crop out the different pieces and components and say, I want to model just this landing gear here. And we'll get to that here in a second. But before we do, you can see that if I do crop things out, I have the ability to do some bridging and hole filling and all kinds of advanced scan editing routines. You can even edit the boundaries of the mesh and extend them and do all kinds of things like that. And in this instance here, I'm using what we call the D feature. So D feature, I can go ahead and window in an area and just say remove this, and it will do all of the erasing and hole filling at once, right? And then again here, I'm just showing the process of kind of setting up my file real quick where I'm saying I want to model this wing as a separate component. I want to model that gun or missile turret thing as a separate component and just copy and paste them as new pieces and then just separate things and break them apart. And again, you'll see that in a minute because when I start doing CAD modeling, I'm going to actually model those as components, right? So these are just little aspects that, again, sometimes we kind of overlook when we're talking about the reverse engineering process. Now we'll go ahead and jump into the CAD modeling functionality of Geomagic Design X. So we'll go ahead and kind of highlight this specific area here. I'm basically just selecting a plane, offsetting it, and cutting through the mesh. And I'm creating what we call a mesh sketch. And this is one of the key functionalities that CAD packages are missing, is that ability to cut a cross section through the mesh. And then here in this instance, I'm actually selecting that mesh and just fitting a spline to it. And then areas that I may not have data, or maybe that is the area where the turret connects or whatever, I'm able to draw and CAD model directly over those areas on my own. And in this instance, what I'm just showing is we can cut a cross section, and we have that section called a mesh sketch and draw wherever we want over top of it. And this is a key component of Design X, to being able to do that. You can see here that I'm just going to create another mesh sketch in this instance and do the same thing. And that pink line is this cross section from the scan data. Now, the first one, I used a fitting algorithm where I just grab the spline and I best fit a spline. And sometimes in these videos, I'm not doing everything the most ideal way. I'm usually showing that functionality exists, and this is how you can do it, right? So in this instance, the second cross section, instead of best fitting it, I actually drew it manually, snapping to what's there. So you see now that I have these two different cross sections, I'm able to just come over here and say I want a loft between those cross sections and create a solid body there. So you see that we are also a CAD modeler, a CAD kernel ourselves. So we have all those scan tools that I talked about extensively there, where I can repair and fix the mesh. But now you see in one software, we have this ability to model directly over top of the mesh with CAD functionality here. So I just took that wing and I use that as a manual process. Now what we're doing here with this component is I am selecting those polygons with a tool there, and then I'm actually creating a region there. And then instead of modeling this manually, I'm telling it to go ahead and use what we call a wizard there. So I said create an extrusion from this area. And what it did is I grabbed that region, said create extrusion, and it just automatically drew the sketch and created it for me. Now I click on the end and I say, hey, let's go ahead and model some of these holes. Let's go ahead and model all of them, actually. And I recognize immediately that it's just a pattern, right? So you can say, I want to best fit circle to these. I want to override it to this specific dimension. I want to make them all equal, so they're all equal radius. And then I want to go ahead and say, I want to make this a pattern. So in this instance, I went ahead and patterned them on 3 individual patterns. But I actually could have actually patterned them all 3 at one time, I realized after thinking about it for a minute. But in this instance, I went ahead and I said, hey, pattern, pattern, pattern. And there is my whole pattern. And I can go ahead and check that compared to the mesh and see exactly how I've modeled it, right? In this instance, I'm going to go ahead and model that. And you see that was history based. I went ahead and extruded it, and I didn't set it to cut. So you see that I'm able to go back inside and edit the extrusion and change it over to a cut. Now going back over to that landing gear, you'll see here, again, even in the middle of the modeling process, if I ever need to jump back and just edit something and remove a bolt or something that might throw off what I'm trying to calculate, I can go ahead and kind of do scan editing and modeling at the same time in here, just the ability to jump back and forth. But what you're seeing here is I select that region on the landing gear and I said, hey, let's use the pipe wizard to fit a pipe to that data itself here, right? And that's all I did is I selected that data, created a region, and then said create pipe. And then this pipe is created as an editable solid. So if I'm not happy with the bend radius or the center line or the cross section, I can always go back and make changes to it. It did all the hard work of creating it, and then I can go back and make modifications to it if I want to, because we're a history-based modeler. And you see there, I went ahead and took that leg and I said, hey, this is the same as the other one. Let's go ahead and just do a manual pattern and pattern it over a certain distance. So it's the same exact component. And then I moved it over. Now what we're saying is let's go ahead and select this bottom piece and use that pipe wizard again, just to show it in a different context, that you can select that information and use these wizards, and it finds the center line for you and even models that for you. So now I'm able to, if I needed to edit anything about that, I can. You see there's my center lines. If I wanted to, in this instance, I only modeled it and there was a coupling between the two. I'm basically saying, let's go ahead and extend that curve out And then once I extend it, let's go ahead and set those as coincident. And you see that the CAD model updates, and even the other instance of the leg updates and intersects with the landing gear. Now, there's a whole host of ways of modeling these things. This is just the approach that I took to go ahead and model it. So some of the other tools that are in here, we're basically doing a collection of lots of different things that would help within an application like this, where you have maintenance on these military vehicles here. Is, you know, if I needed to recreate this door, whether I'm modeling the entire part or just modeling this component here, you see I can create a region on that door panel, and I can adjust the tolerances and do a 3D compare and just see how closely I'm fitting to that mesh. And then I can move the cross sections on this loft wizard that it's creating automatically for me, right? And then I can drag out the different cross sections and then have it create a nice clean surface loft through that information. Now, once I do that, you know, the next steps here, if I was going to create a simple panel like this, is go ahead and create that panel and then extrude and create a plane here. And you see I can draw the outline. And in this instance, instead of even doing a mesh sketch, I'm just visually drawing how I want the cross section to be. So you see here, I'm just zooming in and just identifying where I want that to be. And again, there's lots of different methods to do this. I'm just showing a collection of different ways that you could go about this. Because I showed mesh sketching before, you can even skip over the mesh and just draw directly what you want in 3D space as well. So I'm adding my fillets in there, and you see that I can dimension, I can add constraints to the sketch and relations. In this instance, I'm doing a surface extrude, and then I'm just going to do a surface trim between those and just keep that middle piece and get rid of the rest, and then thicken this to create the surface panel here. So you see there, just in a couple minutes, we're able to fit a surface with a surface loft and then create a panel on that side. So that's using a surface loft and some surface trimming techniques. Now here's another example of, here's another like cover that we want. So again, when we're modeling something, this is all one giant piece. I can go ahead and separate that piece out. And let's say that I want to model this guy and make another surface panel here, but this one's going to take some different techniques here. I'm going to add some regions. In the regions, you can create regions on the entire part, but you'll notice that what I'm doing here is I'm creating regions manually as needed. And the way I like to think about them is I can use them to region the entire piece, or I can use them as saved selections, where I just select those triangles, create a region, and I can always go back and reselect it again. Now here's another instance where I actually used the extrusion wizard, and it didn't give me exactly what I wanted. So the wizard did all the heavy work for me to create. So what I went ahead and did is I let it give me what it gave me, and then I went ahead and rebuilt that curve in like 2 minutes to create a nice clean curve. So even if a wizard doesn't give you exactly what you want, remember we were talking about this as a history-based CAD modeler, it still gives me the history to work with, the model that it gives me from those automatic tools, and then I'm able to work with them and create better geometry from there. So here, what we're doing is we're creating all the surfaces that would create this shape, right? And in that last instance, instead of doing a lofted surface, I went ahead and did a mesh fit. So I just used that one instead, just to show that there's another method to use, where I created this mesh fit to fit on that flange, the orange region. And then you'll see here that as you draw things, you'll see, is this an arc? Is this a curve? Should I use a spline for this? You can, as you visually draw, you can identify what it should be, and then you can then figure out what that should be and then apply the dimensions and constraints from there. So you see, now I'm going to go into the trimming phase, where I'll go ahead and trim those surfaces together, add a fillet there, and then trim all of these together from from there on out. So you see now we just trimmed all those components and add some finishing features like fillets and stuff there to create that panel, so a replacement panel for that side. So many of these aircraft will stay in the air for much longer than they originally thought. When they have a really good design, they'll stick with it for a long time. And bringing a lot of these aftermarket parts into the modern age of being able to scan all these old designs that lasted way longer, maybe certain airframes are repurposed for different duties within the armed forces, you're able to bring in all these old designs and create aftermarket parts, rebuild them, bring all of the files into the digital age. So now, in this instance, I'm showing another piece of functionality that I really like to use a lot, and this is the boundary fit surfacing tool. So you can just draw 3D curves anywhere on the shape. And these are along the lines of what the original designer might have done if he used CAD or however they designed this originally, right? And I can just draw out this curve network based on the curve components here, because that's another panel there. And I can say fit surfaces to these boundaries, but yet the interior of those surfaces fits to the mesh. And you see it's editable. So when I created the first one, it was a little bit ripply because the actual surface, this is an old helicopter that's had lots of repairs and things done to it. So you'll see the surfaces are wavy. I'm able to just smooth those out and create this nice surface, and then go ahead and thicken it into a solid. And you'll notice, because it's all history based, I changed my mind and I wanted to extend the boundary there in order to create a solid piece and extend the boundary out to the edge of where it was before. So here's a few other applications and use cases that we've done in the past. You see, a lot of the stuff that we end up showing, just like Kyle mentioned earlier, is stuff that's older or retired, because obviously this type of information for defense things you're not sharing publicly. So we're using all these old examples of how you can use this within these types of applications, whether it's modeling an entire aircraft, as you see on the top left, this Phantom. We modeled the entire aircraft, the exterior there, or the top right here, this tank, that we were able to model the entire thing, or drones, or in here the comms, being able to model the entire assemblies. And this is what I'm talking about when we talk about time savings. If all this modeling is a simple block with extruded features and some holes, yeah, DX is going to save me a little bit of time. But when you model this entire thing, it's going to exponentially save time being able to model directly on the scan data. And it's essentially extracting the dimensions for you from the scan data. So now we'll go ahead and transition into a Q&A session. If anybody has any questions, you could submit those in the chat, and I'll turn it over to Guy to kind of manage that.
Awesome. Thank you, guys. Really interesting presentation. It's great to see how the tools that you're showing aren't just useful for reverse engineering this specific helicopter, but the breadth of applications that you can apply them to. As Greg said, if you've got any questions, it looks like we have a few here. If you have any questions while these are being answered, then feel free to drop them in the questions area. So this first one here is one for you, Kyle, about the NimbleTrack. So how long do the batteries last on the tracker and the scanner?
Yeah, that's a great question. So I think we saw on part of that video, you can see the 2 camera batteries on the back of the tracker. Those are hot swappable, so I can take one off and still have the tracker running while I take back and forth. It's about a 2-hour time window, 2.5 hours. I've seen it go a little bit longer, but it's kind of the standard recommended time for the tracker. And then for the scanner, the batteries are in there, these kind of round 2-wheeler batteries. Again, 20, 30 bucks, pretty cheap, easily available. And those are about an hour and a half to 2 hours of scanning. I've seen as well too. Also hot swappable. So on the handheld, I would take the battery out, put the new one in, and it would automatically reconnect to the network, and then you're ready to scan again. You don't have to restart the scan or start over, anything like that. You can just pick up and keep going right where you left off.
Great. A few more here about the scanner. It's a popular topic. How much does the scanner weigh? That's I'm sure on a lot of people's minds. You don't want to be absolutely knackered trying to carry that around all day.
Yeah, you get giant shoulders. No, it's a little bit smaller form factor than the old, the bigger handheld ones that we've seen in the past. It's about 40% smaller. It's really only about 1.5 pounds. It's really light to actually hold in your hand, and with that battery inside, right where the handle is, it's really nice kind of weight distribution. Pretty easy to scan. You saw Brian; he's not a huge buff guy by any means, and he scanned the whole thing in a couple hours, and he didn't complain about soreness afterwards. So anyway,
great. And does the scanner capture textures? That's a question we've got here.
Yeah, I'm assuming in our world, right, in the 3D scanning world, sometimes when someone says texture, they mean color, and the scanner does not capture any color. It's just that standard kind of blue, mesh color is really the only color it's going to capture. Yeah.
Great. There's a question here for you, Greg, around Design X. You mentioned about the workflow of taking CAD out of the reverse engineering package for other downstream processes. Can you tell us a little bit more about what that looks like?
Absolutely, yeah. So there is a piece of functionality within Design X once you create these components where you can send it over, live transfer it over into Design X. So what it'll do is it'll build the history tree over there, line by line, the sketch and the feature over inside of CAD. So yeah, that's how you get that over there, is by live transferring it over. And it supports SolidWorks, NX, Pro E, Inventor as well. So
great, thank you. We have a question here, not necessarily, well, actually, definitely necessarily about the NimbleTrack. So we've got one. I usually work with a Faro scan arm. The arm is the reference point 0. How does the handheld make a reference point?
Okay. Well, I know with an arm, the way it works is the base is XYZ0. I understand that. Really, when you first start the scan, that is going to be your X and Y right there. But it's something that's very easily in the software. You can align it. And if that doesn't answer your question, maybe let's talk offline to make sure I understand exactly what you're asking. But
yeah, I'll comment a little bit on that too. Like, the arm has its own coordinate system, and obviously you can scan in there. And then the NimbleTrack has a coordinate system, right, where it's the base of wherever you started from usually. And we can actually use the geometry to put the scans together if you were trying to align data from 2 different sources, right? Sometimes people are asking that, whether they want to have data from 2 different kinds of devices, right? So we can align those inside of Design X. That's another assumption I'm making as well. Like, if that's what you're trying to do, that's another possibility.
And this question kind of leads on from that one. How is the handheld scanner then calibrated?
That's a great question. So there's a local calibration you can do with the scanner and the tracker both. The tracker will calibrate by itself. The scanner will calibrate in conjunction with the tracker and the volume. And the volume of the tracker scanner is about 4 feet wide at the front, about 10 feet long, and about 6 or 8 feet wide and tall in the back. So the size of let's say a side-by-side 4-wheeler or smart car, something like that. And I'll do it all locally.
Great, thank you. A question for you here, Greg. What is the best way to control the CAD dimensioning in Design X? How can you be sure about the dimensions?
So I usually, when I hear people ask that question, I usually say that's the engineering part of the reverse engineering. So when we capture these dimensions from devices like this, it's capturing the exact existing condition, right? So for an example, if the bolt hole is a 3-inch hole, it's never exactly 3 inches, right? I mean, if your manufacturer is capable of doing that, we need to talk and figure out what they're doing, right? So it's like, 2.98725, whatever, if it's really accurate. And my software has the ability to fit exactly to it, right? So it would fit and average out and create that, 2.97, whatever. And then DX also has the ability to add the design intent. So then once I fit that circle, I could then override it and make it 3 inches and infer that that must have been a 3-inch circle if it was that, right? So there has to be at least a little bit of knowledge of understanding what you're trying to create and what the tolerances are based on the size and scale, purpose, the materials involved. And again, that's the engineering side. And our software does have that ability to round and average and all those other things. But yeah, one of the things that Design X is giving you is the ability to either fit things as existing condition, like just like they come from the scanner, or actually fit them and override them as what we call design intent. So you have both options, and you can even use both of them at the same time within Design X. So yeah, that's a great question that people often ask.
Great, thank you. Back to you, Carl. Another scanner question. I can't remember if you had mentioned this in the bulk of the presentation, but we've got a question asking about the accuracy of the NimbleTrack.
Yeah, great questions. There's really two answers with the way we calculate the accuracy of the scanner and tracker itself. One is a single point accuracy, so that's kind of a local small area accuracy. That's 20 microns or 0.8 single point accuracy in a small area. Volumetric accuracy over, again, that kind of distance that we talked about, the smart car or the side-by-side four-wheeler type thing, we're going to be around 49 microns or just under 2 thou for an entire volume, front to back, side to side, corner, top and bottom.
That looks like we have one more question, but I'll hold it for the end because it kind of moves us on to our final slide of the presentation. Have we got any other questions for our experts here today before we talk about next steps? I'll give everyone a couple of seconds to drop anything in if they've got any last minute
coffee cup down.
Guy, I had one thing to add too, maybe. Just one thing that's really neat about the NimbleTrack that we didn't show in the video there with Brian is it actually is a handheld scanner by itself. So I could literally turn the tracker off and put targets down like a standard handheld scanner and scan with it completely by itself, not with the tracker at all. So it's like a independent scanner, just if you had your own kind of handheld scanner as well too. So it's kind of a neat thing we didn't show in that video, but it's kind of a cool thing on a big part like that. Maybe you want to scan an occluded area that you can't see with the tracker. That's how you can do that.
That's cool. Yeah, so use the sticker targets locally on an object, or you can extend the volume and make it bigger with that. That's really cool.
Yep.
Awesome. We've got one here, more of a logistical one for actually using the scanner. How big is the scanner? How big does it pack down to?
Yeah, comes into a case not quite the size of, let's call it a tuba case or something like that. Someone asked about a ferro arm earlier. It's smaller than a ferro arm case, about only 60% the size of like a ferro arm case, but it's all encompassed in one case that's maybe 18 inches wide, 10 inches deep, 3 feet long, something like that. That's got the scanner, the tracker, the tripod, the batteries, Wi-Fi router, everything, all the bits and pieces right inside of it. So it's on rollers. So I can roll it around. About 30 pounds, I think, something like that, but it's on roller, so it's pretty easy.
Right.
Good question.
We have a few more coming in here as well now. What's the smallest objects that you can scan with the NimbleTrack?
Yeah, very small, tight resolution on the NimbleTrack itself. We can scan things as small as well. I like to hold up this little piece here and show I can get the details on something as finite as this if I wanted to, all those raw edges, or something like a dime, the grooves on the side of a dime, or the numbers and hairs of whoever it is on the front of a dime, something as small as that.
Great. And another one about the scanner. Obviously, it's a wireless scanner, but is there the ability to wire it up for I assume longer battery life?
Yep, absolutely. It's able to be plugged in completely. I can plug in for power. I can plug in for connection to the laptop as well too. And the cool thing about when it's plugged in is when it's not plugged in, it measures at 2.5 million measurements per second, which is just about as faster than just about anything else available on the market. When it's plugged in, it actually doubles the frame rate to 5 million measurements per second, which is you can't move your hand fast enough almost to scan when it's plugged in.
Right, and kind of moving on from the accuracy of the scanner, we've got a question about the point spacing, the resolution.
Yeah, you bet. Resolution on that scanner is going to be 25 microns, so it can scan something as small as that or get details as small as that. It'll make triangles as small as 25 microns. So every triangle in the STL or mesh file is going to be that small, about as small as what you can even see, and it's a triangle. So very small, finite details. Some things we've scanned with scanners with the same resolution are a tooth of a bird or something like that, something really finite where you've got little grooves or human teeth for that matter, things really small, detailed, finite.
Right. Back to Design X here. I can't say I fully understand this question, but Greg, as the Design X surfacing expert, I'm sure you'll be able to help out here. How can we reduce the surfaces being torn while using neutral formats like STEP or Parasolids to transfer the model to other softwares?
What was the first part again? Just read that first part again.
How can we reduce the surfaces being torn while using neutral formats?
Okay, I think what's going on is in translation, sometimes you can save in and out the tolerances of the file, right? Well, one of the things is exactly what we talked about before, is if I use the live transfer over to the CAD instead as a more native format, you can kind of bypass the whole translation functionality altogether. That's one thing that you can do. And then the other one is we try to save in a neutral format that is more relative to where we're going. So if I'm going to NX, if I save it out as a Parasolid neutral file, if that's what I'm doing, is trying to save out, instead of using an IGES, which is your lowest common denominator, or STEP, which are pretty good, right? Sometimes I see benefits in saving to that Parasolids or an SAP for the ASYS kernel softwares like CATIA. So if you save out those, sometimes you get a little bit better translation from one to another. And then those softwares are able to open them because you're throwing it in their native container. Those are a couple tips that I can think of, but if you have more questions or more specific examples, we're always happy to talk about those sort of things offline, and we'll give out the contact information here on the slide, and we can contact and talk specifically about your exact issue and ways we can overcome it. So
awesome, thank you guys. The last two questions we had, I've holding them for the end just because they lead on to the information we've got on this slide. So we had a question about how to get a demo, a personalized demo for the scanner, and also a question about the price of the scanner. Anyone that has joined this webinar today, you can see on the screen, we will be running an exclusive special offer for this as a reverse engineering bundle. You'll receive more information, you'll receive the recording of this webinar, all of the contact information for follow-up. The guys here will absolutely be following up with questions, ensuring that you've got all the answers you need, following up in case we need to have a deeper discussion about some of these topics. But we'll look out, or you guys look out for the email that will be coming out next week. There'll be information on this as a special offer, information on how you can get hold of Kyle, how you can get hold of Greg, and understand a little bit more about how you can apply this technology to your specific applications. That looks like to be the last of the questions. Unless there's any other burning questions, I'd like to thank the presenters today, Kyle at Digitize and Greg from Oqton. It's been a really, really interesting session. You can see that by the volume of questions that we've had at the end here. So Really appreciate your time. Thank you everyone for taking the time to join at this time on a Friday. Look out, as I said, for the email next week. We'll be following up with everyone here to ensure that you got the most out of this webinar, and we're always welcoming feedback and questions and anything else as a result of this webinar. So I'd like to thank you all for joining. Thank you guys for presenting, and have a good weekend.
Thank you. Thanks, guy.
Thank you.